Its name is Betelgeuse, a red supergiant known for its sheer size and intensity. But recently, it's been dimming, pulsing, and spinning in ways that defy expectations. These anomalies have triggered intense global interest, sparking a cascade of new observations and theories. Now, scientists are asking a startling question: is Betelgeuse dancing with an invisible partner? At the heart of this unfolding mystery is a star so immense it could swallow Mercury, Venus, Earth, and Mars if it were placed in our solar system. Despite its glowing prominence in the night sky, something seems to be subtly influencing its behavior, perhaps something hidden, faint, and cloaked in cosmic dust. This unseen influence may be the missing piece in understanding Betelgeuse's bizarre activity. In this episode of Cosmic Investigation, we'll dive into the strange signs surrounding Betelgeuse and explore a growing theory that could rewrite how we understand massive stars and their final moments. Betelgeuse, perched on Orion's shoulder, has been a subject of wonder for centuries. Easily visible to the naked eye, it glows with a deep, reddish hue, a signal of its colossal size and cool surface. But in recent years, it's proven to be more than just massive. It's volatile. In late 2019, astronomers worldwide were startled when Betelgeuse suddenly dimmed, significantly and unexpectedly. The dramatic drop in brightness was so abrupt that it sparked rumors of an imminent supernova. Scientists and skywatchers alike braced for what might have been the brightest supernova ever observed by humanity. However, further analysis revealed a different explanation. The star had likely expelled a massive cloud of dust, which temporarily obscured its light from Earth. The star didn't explode. But the event raised a more profound question: what exactly is happening inside or around Betelgeuse? Betelgeuse's brightness isn't constant. It naturally fluctuates over time due to internal pulsations, waves of expansion and contraction within its outer layers. These pulsations are expected for a red supergiant of its age and size. But there's one specific rhythm that stands out: a slow, repeating pattern roughly every 6 years. This long secondary period is too regular to be written off as internal turbulence. It hints at an external source of influence, potentially the gravitational pull of a hidden companion. That theory gained credibility as astronomers speculated that Betelgeuse might be part of a binary system, with a low-mass star orbiting nearby. If real, this companion would orbit at a distance similar to where Saturn circles the Sun, far enough to be elusive, but close enough to affect Betelgeuse's behavior. To investigate, a team led by astronomer Jared Goldberg used the Hubble Space Telescope's ultraviolet spectrograph. Their goal was to catch glimpses of this hidden partner. They targeted specific wavelengths that could reveal a faint, hot object, something that wouldn't be visible in regular light due to Betelgeuse's overwhelming glare. Unfortunately, they didn't find a definitive companion. Betelgeuse's brightness and the surrounding dust made it nearly impossible to spot anything directly. But the lack of visual confirmation didn't rule out the possibility. Instead, the mystery deepened. More clues began to suggest something is out there, something unseen, but undeniably influential. One of the biggest puzzles is Betelgeuse's unexpectedly rapid rotation. Red supergiants this old and this large should have slowed down long ago due to the conservation of angular momentum. Yet Betelgeuse spins at roughly 5 to 15 kilometers per second, far faster than expected. This anomaly might be explained by the gravitational pull of a nearby object. A companion star could be applying tidal forces, much like how the Moon affects Earth's tides, helping to maintain Betelgeuse's spin rate. Then there's the regular dimming, the roughly 200-day pulse. If a smaller star is orbiting nearby, its gravitational pull could be stretching and disturbing Betelgeuse's outer layers. This might trigger predictable changes in brightness and shape. Interestingly, most massive stars are born in binary or multistar systems. A truly solitary giant would actually be the exception, not the norm. That makes the idea of a companion even more plausible. Some researchers have also considered whether Betelgeuse may have merged with a smaller star in the past. Such a merger would explain its mass and spin characteristics, absorbing angular momentum and material from the companion. However, that wouldn't explain the ongoing rhythmic changes we see today. The evidence increasingly points toward a current, unseen companion. This companion wouldn't stop Betelgeuse's eventual supernova, but it could shape how that end unfolds. It might influence how the star sheds its outer layers, forms dust, and even how it explodes. Betelgeuse is surrounded by intricate clouds of gas and dust, likely the result of massive material ejections. A close orbiting companion might be responsible, disturbing the star's atmosphere, triggering the expulsion of gas and dust that later blocks its light. What might look like a sudden stellar eruption could actually be a gravitational tug, a nudge from a hidden star in orbit. Understanding this could be the key to predicting supernova behavior across the cosmos. If we confirm that Betelgeuse has a companion, it could redefine how we study stellar death. First, it would give us a living example of how red supergiants interact with smaller stars in the late stages of life. These interactions are already thought to drive events like Type II supernovae and neutron star collisions. But Betelgeuse offers a different kind of system, a volatile, dying star influenced by something smaller, but still significant. Second, it could transform how we study mass loss in massive stars. Companions could act as triggers for the massive outflows of gas that later influence the type and brightness of the eventual explosion. Third, it could help us build better models for supernova prediction. If we can trace how a companion affects a star's spin, shape, and material envelope, we may gain insight into how long these stars have left before they go supernova, even if it's still thousands of years away. Future missions like the James Webb Space Telescope may finally have the precision and infrared sensitivity needed to cut through the dust and catch a direct image of this hidden companion. Meanwhile, Earth-based observatories will continue tracking Betelgeuse's light curve, monitoring its pulse, and checking for spectral shifts. If the 6-year cycle holds, we'll have more chances to test whether something is truly orbiting this mysterious giant. What makes this investigation so powerful is that it's happening in real time. With a star visible to the naked eye, you can walk outside, look up at Orion, and see Betelgeuse blinking back at you, carrying with it the secrets of a long, slow transformation. Whether that transformation is being influenced by a hidden star, a past merger, or something entirely unexpected, we are closer than ever to finding out. Because Betelgeuse isn't just a star nearing the end. It's a cosmic puzzle, and its final act might be more spectacular and more complex than we ever imagined. Consider this. If Betelgeuse explodes in our lifetime, and that's still a big if, it could shine as brightly as the full moon in our night sky for weeks or even months. That would make it the closest supernova visible to Earth in modern history. But the explosion itself might also be asymmetric or shaped in strange ways due to the gravitational influence of the companion. We might see lobes of material, polarized light, or even unusual gamma-ray bursts that don't align with traditional supernova templates. And the impact wouldn't just be visual. Scientists would use the opportunity to observe neutrinos, gravitational waves, and high-energy particles in real time, offering unprecedented insight into the death of a massive star. Betelgeuse could become a Rosetta Stone for understanding the most dramatic event in stellar evolution. All this from a mysterious, flickering red point in our winter skies. So as we continue scanning the heavens, peering through dust with powerful telescopes and measuring subtle shifts in starlight, we do so not just to satisfy curiosity, but to uncover the deeper forces at work in our universe. Forces that stretch across gravity, light, and time. And stars like Betelgeuse remind us that even the most ancient celestial objects can still surprise us. In a universe that never stops changing, Betelgeuse stands as both a relic of the past and a harbinger of cosmic rebirth. The invisible partner, if real, is not just a companion, it is a silent sculptor of stellar destiny. And the dance they share may be the last, brilliant waltz before one of the grandest shows in the cosmos begins. These discoveries also reopen long-standing questions